Hey guys, so now we're doing the 54 line prime number generator. So I'm going to go through this really quickly and we'll also get a quick preview. Just so you know, both my perfect number generator and my prime number generator are going to be on my Python images and logos repository in GitHub. So there's been a bit of an update. The Python images and logos, I couldn't figure out how to rename it, so I just decided to go with it, stick with it. And so now basically every single Python thing that I do is on that. So now get in. So, to not make this video way too long. So we need to make this eligible for Python 2, because I've coded this specifically so it's available for both Python 2 and Python 3. So it starts with an import from future. So the future, import the print function. Then import sys. Then defines generate primes limit. Just like perfect numbers, it's generate primes, which does basically both together. So it's going to do actually a bunch of try except here. So then what we can do is, there's a try. It's going to try and validate the input. So if not is instance, limit and int. So int. Then or. So if not is instance, this is not an or. Limit is less than 2. Raise a value error. Limit must be an integer greater than or equal to 2. So it must be an integer, as described here, and it has to be greater than 2, not less than 2. And then the initialization for the sieve array. Sieve equals true. Was that? Hold on. I need to check something. Yep. True. Multiplied. Limit plus 1. Okay, I don't need that. Sieve equals 0 equals sieve equals 1 equals false. So that puts a bunch of logic, which starts to get confusing when you go way too far into it. Then it implements the sieve into that word. It took me a long time to Google and find that. So I'm not going to try and do that again. So it's going to do all this. And then it's going to have an if statement, if sieve I for j in range I times I, limit plus 1, I sieve j equals false. Then it generates the list of primes. Primes equals num for num in range 2. So it starts from 2, and then the limit plus 1. If sieve num. Num is sieve is the other array sieve that we've created. And so what we're going to try and pick up here is how there's also, after that, if there's any exception of a memory error and it can't generate enough primes to that limit, it's going to print it can't, and it's going to return nothing or none described in Python. Then an exception as exception, an other exception doesn't know, it brings that in as E. Yeah, when I highlight that, there's a lot of E's in this entire Then it's going to print an unexpected error occurred. And then it's going to put in 0, format, string, E. And then it's going to return nothing again, as exceptions shouldn't really return anything. Then the main is where it's going to, if sys.versioninfo 0 is less than 3, limit equals int raw input and generate primes up to. So it's going to be a raw input. And it's going to be an integer too, because you convert that to an integer from a raw input from it. Yeah. So then else, limit equals int input generate primes up to. So that's going to be a normal input instead of that keyword. That. Yeah. So this is actually just for if it's Python 3 or Python 2. If it's Python 3, I'm pretty sure, yeah, it does one of these for Python 3, one of these for Python 2. And that's an if-else statement, so only one of them runs. Then primes equals is generate primes limit. So it's going to use the generate primes function. If primes is not none, so if the primes is not none, so there's not any primes. If there's not any prime, okay, yeah. If there is primes in there, then it will print primes up to that format limit primes. So the dot format limit primes, what it's going to do is, so these are index numbers. I may have not told you what these mean, but these are like formats. So when it puts dot format limit primes, pretty sure this is how I coded it, but because I coded this like 2 weeks ago. So I put this, I'm pretty sure the index of here matches these numbers. So 0, index, this is 0, 1, index, this is 1. So primes, the amount of primes is going to show here, limit is going to show here. So much harder in Python 2 though. And then, so after that, it's going to have, after that try in def main, it's going to have an exception list, basically, which with the value error as VE. Invalid input, 0, format string VE. So it's going to show you the error in there, right there, just like in the rest. Then another exception. If another exception comes, keyboard interrupt, meaning you could just randomly click a key and just do that, then it's going to say operation canceled by user. And then if there's another exception, it's going to say an unexpected error occurred, and it's going to show you that error. Then, finally, so it's this list is always going to come. So this is always going to execute no matter what. It's going to say print. It's going to print program execution complete. Then this if name equals main thing is just to make sure that it's not running as the main branch when it's not the main file that's meant to be executed. So that's it. Now we can check this. We can run it. So I'm going to do at least here. What I'm going to do, I'm not going to do too much, because one time I did 1,000,000. I couldn't even scroll through the list. It was that laggy. So what we're going to do, let's do 100. 100. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, and then that's it. So today I am actually explaining most of, so you know how, so a few, like maybe some time ago, I made a prime number generator. For some reason VS Code is not installed again. It just kind of uninstalled itself for some reason. I'm just gonna get that really quickly. So while this is downloading, I just want to tell you about what we're doing today. So what we're doing today is basically we are taking the prime number generator that I made in another video. Go check that out. And explaining the Sieve of Eratosthenes. So I majorly kind of shortened the video by explaining that it took me quite a long time to research a bit and how to do it in Python, and I couldn't really go over it all over again. So this is the video I do go all over it again. So, okay, is this done yet? Okay, this is gonna take a while. Anyways, while we're at that, I want to show you my VS Code folder. So this is the thing we are going. What in the world just happened? I don't even need this anymore. Don't. There. No. That. Quit. Quit anyways. Okay. Well, I guess we're in anyways, so we're back to what I was going to talk about. I'm sorry if my voice was a bit low because the mic's not that close to my face now. So, what we're doing today is so I'm going to explain all of the, the Sieve of Eratosthenes, how it makes prime numbers, things like that. This one's a very slow version because, as you can see, hold on. That. Hold on, desktop, I think. It's desktop. No, desktop. Yeah, that. So, like I was saying, maybe it'd be like the third time I repeated it. So, we have the perfect number generator that I've showed you in the other video. I don't know why the command line extensions keeps coming up. This is the perfect number generator, but we're not talking about that today. This is the prime number generator with try and accept, really fast, really efficient. Then this is the base of it. So this is what we're going to be talking about today. So how this one function does everything this does, like 54 lines of code. So 22 lines of code does everything 54 lines of code does, but it's kind of smaller. So, and it's a bit less efficient. So one night I was like working on this like all over again, like making the function itself instead of being an array and having to like, floor division, all that. So what we're doing here is this is the function Sieve of Eratosthenes. So these lists make it, so this makes the list. These are the lists for the prime numbers, the composite numbers, and the numbers that are not sorted yet. So the numbers not sorted is actually not really like not sorted. It's more of every single number from 2 to that parameter plus 1. So soon, if you're watching this video, I might like soon make a video on like how to simplify all this code, how to like make it understandable, and how you can use it just to understand the rest of my videos perhaps. So yeah. So now how you do this is, so not sorted, not primes, and primes. Not primes is also known as composite numbers. So how it works is p equals 2, right? So we set that there, so it's the smallest prime to find multiples later in the code to put in the not primes. So first we need to fill up the not sorted list, because that's actually quite important. So how this is going to work is we are going to take, so I in range 2 to n plus 1. So n plus 1 is the parameter plus 1 because for some reason Python, it goes 1, it starts from 0 and goes to 1 below the parameter that you put in the range piece in the for loops. I don't know why it does that, but it's just how it's made, so I kind of like it that way. So 2, so it tells it to specifically start at 2 and not 0, and go to n plus 1 because otherwise it will just go to n minus 1. So this makes it be inclusive of n itself. So how this is going to work is it includes 2 all the way to n plus 1. So it's basically 2 to n, but it's inclusive. So how this works is now you've appended every single number that you need. And for p in range, so we're using this variable again, 2 to n plus 1, you put a for loop inside of a for loop, so you nest them. So how it works here, this is kind of complicated to explain. Hold on, I'm going to highlight it so you can see exactly what I'm talking about here. So what it does is, this is a for loop, right? Then inside of that is for loop. So it for p in range 2 n plus 1. So I think this is kind of majorly flawed here, perhaps, as p is being changed twice, and I don't think that's needed. I may have made a flaw in my own code. So the p, the variable, which is prime, that's probably why it's called p. Yeah, that's why I named it p. And then x, which is the second factor, in this. So it's going to append this, specifically not primes, because it's basically every single one to that one. So yeah, this p equals p plus 1. If you want to do it way faster, just do this here and remove that. Hold on, let me do that really quick. Ah, no. That, no, that, no. Cancel. Yeah, let's just don't save. And now we open that all over again so I can actually fix this for good. Or perhaps not, because it probably doesn't really matter right now. But I'll put the fixed version after I test all of the versions in my GitHub. So yeah, stick around for that. So now what we do is here is where for p in range, hold on, is this recording? Yeah, it is. For p in range 2 to n plus 1, for x in range 2 to n plus 1 again. So it's these two are both inclusive. So this is where you find all the multiples from the variable p, which I explained over here. Oh gosh. So here is where we take not primes and we append x. So that is always going to change times p, which is always going to change in the x for loop, that means we won't need this one. And I'm just going to move everything back again right now, so now I don't need to do it off screen, so yeah, now that happens. So X changes every rotation, P changes every rotation, and essentially what happens here is you find every single multiple up to n plus 1, so it's inclusive of n, and what you do after that, so then you p equals p plus 1, change it by 1, then you do multiple other things that, excuse me, I burped. um, for a, so this is a new variable, so we don't perhaps somehow cross, do something that just messes everything up here. So it's I, then, so there's I here, then X here, with P there too. Then for A in range, length of not sorted, so that, the length of that, so it's going to go for this many lengths, and since it counts from 0 to 1 minus that parameter, this also, the lists do too. So the index that we find for every single value or item in there is going to be recorded, like, it's kind of hard to explain. Hold on. Yeah, so I think I remember now. Essentially, this counts from 0 to this minus 1. And this also counts from 0 as the first index, as if there's like if there's 6 items in a Python list, it will count as there's 0, 1, 2, 3, 4, 5 instead of 1, 2, 3, 4, 5, 6, just as the for loops. So essentially how this works is it lines up perfectly. So then there's an if statement with the not logic gate, essentially. So this is more of logic right now here. So if anything and not sorted with that in the index of A while it keeps changing, because you know why I told you that it hopefully don't need to go all over again because that took like a minute. So then if something here is not in something here, like, and those numbers were actually created here, like I told you. So if it's not there, it's going to append that to primes, and after it does every single one of that, and that's in a for loop, so it does every single index, it's going to print primes. So let me see if this works without having to, yeah. So let's do 10. 1, 2, 3, 2, 3, 5, 6, 7, 8, 10. Yep, that does not work because 6 is not prime. Yeah, that. Hold on, did it save? No, it saved. 4 P in range 2. Hold on, while I just fix this. Like that. Then tab this a bunch. Tab, 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 tab. Yep, there. So now that's like that, and it's hopefully fixed. Save, and we can kill the terminal. Kill the terminal completely. And let's go all over again. So 10. Now it should work correctly. 2, 3, 5, 7. So that's correct. Now if you go something higher like 1000, it's going to take a while because it's not the fastest way to do it. Because like I said, that's the fastest way to do it, but after like a few seconds, it does it. And as you can see, it prints every single one of them with commas. So, well, yeah, it's a good way to find stuff. I'm gonna try and maybe in another video, I'm gonna try and work on something perhaps that can calculate like circumference and stuff, but that's probably gonna be really hard to include pi in there. So, let's compare that to this. So like 5-ish seconds for 1,000. Hold on. My gosh. 1,000. And that does it in a quick instance, no delay. Now hold on. I'm just going to run a quick Python program checking if they're equal. Because if they are equal, congratulations, because that is now going to be in the description. Otherwise, I'm just going to tweak it a bit, you know. And I did test it a bunch of times, but, you know, just got to make sure. Test test is not plain text. It's going to be, no, I don't have any of those languages. Python. If, hold on, high equals command V. That's really insane. Hold on, I think I go to the end. Enter. High equals this is about to be the moment of truth. Now I do that again. If high equals high, print yay. So that should work. Yay, they are equal. So that means I'm just going to close that out. Okay, is that there? No, is that there forever? Yeah, we won't need test anymore. Move to trash. So that's official. It works. It's good. And that is the framework of this entire sieve here. So this Sieve of Eratosthenes. I actually just figured out how to correctly pronounce that. My dad kept like giving up like random names to try and pronounce it. None of them worked. So here it goes. It basically how this works. What does that mean again? Anyways, so it's a for loop with 2 to integer of limit. Limit is actually n in our case. And then if sieve I for j in range I times I limit plus 1 I you know, sieve j equals false. So this stuff is actually just a much more complicated, like more compact version, I'd say, of this. I mean, I know I could just make it the function, but that would increase the gigabytes, that would increase everything and just crash the functionality. So that's it for today's video. I hope I see you later. See you in the next video. Bye guys.